This is The Second Studio, hosted by the Architecture and Design Office fame. My name is David Lee, and with me is Marina Borderonay. The two of us are partners at the office, architects and hosts of the show. And today we're talking about designing a house that is fire resistant. And of course, this is in response to the recent and tragic wildfires that swept across Los Angeles. Sponsors.
Designers and architects, if you're looking for a powerful and real-time visualization and VR tool, then check out Enscape. Why is Enscape special? Well, it's super easy to use because it's a plugin and not a standalone application, which means you can work directly in your SketchUp, Rhino, ArchiCAD, Vectorworks, or Revit model. It only takes a couple clicks from installation to creating your first rendering. Enscape does realistic renderings, 360-degree panoramas and videos, and virtual reality environment. We use Enscape and we think you will love it too, so click the Enscape 3D link in our show notes to learn more.
I used to start remodeling projects with hours of tedious measuring and recreating the existing conditions. Then I discovered Canvas, an iPad and iPhone app that lets me easily scan entire homes in minutes and automatically generates editable models in formats like SketchUp, ArchiCAD, Vectorworks, Revit, and more in as little as one day. Thanks to Canvas, I spend more time designing the future instead of measuring the past. Get to the design phase faster with Canvas. Visit canvas.io/SSP or click the link in our show notes to schedule your demo and get your first as-built free. This is The Second Studio with myself and Marina. Here we go. If you're not familiar with our office, we practice both in San Francisco and Los Angeles and other states as well. But those are the two main territories, and we are currently helping a few people through the rebuild process to rebuild their houses or do a new house in Los Angeles. And so what we hope to do is help those clients, but also through the show and our office in general, is to just be a resource. So anybody who has questions about navigating this specific process in LA or fire resiliency design in general, reach out to us. And I should also mention that as an office, we decided to offer some of the initial services we do for a project complimentary for anyone who's needing to build a house, rebuild a house because they lost theirs in the fire.
Yeah, we're doing that to help people hopefully get back on their feet and give them a direction. If they move forward with us on the project or not, it doesn't really matter at this point. It's more like giving them the energy to, look forward to the next thing and getting their life back on track.
Absolutely, because it's chaos right now for most people who lost their houses. And as everyone knows, with any normal architecture project, it's a huge thing to start.
Big undertaking.
The beginning is the difficult part. So we're trying to make that easier for folks. And also, I will say specifically in the Pacific Palisades, the rebuild process is not as straightforward as one would hope.
They're still figuring it out.
The city's still trying to figure it out, right?
There's a lot to navigate.
Exactly. Do I keep my foundations? Do I do a rebuild? Do I do new construction? What happens in the approvals? All of these things. So again, feel free to reach out because we're in it and we're more than happy to share the information we have.
Yeah.
So the first thing we should cover is the 3 different ways that wildfire spreads in a neighborhood setting.
Yes. So there is, let's say, 3 ways that can happen, right? The first one is, of course, direct contact to flame. That's the most obvious,
makes sense, right?
How any fire starts. The second one is embers flying away from where where the fire started and creating more fires, for it to spread. And the third one, which maybe is one that people don't think about very often, is the radiant heat that's created by the fire that could get materials and things to ignite and spread the fire as well.
And so radiant heat meaning that the material that is going to burn or is going to be destroyed is actually not in direct contact with the flame. But of course, fire makes the atmosphere extremely hot, which is radiant heat. I read an interesting fact about embers that I think it was 90% of the spread is most of the time is caused by embers. And I think it's interesting because when most people hear the word embers, we tend to think of the small, tiny floating things that are created by a campfire. But when you have something the scale of the Los Angeles fires or a wildfire, the embers can be very large. So I think it was reported that some folks saw embers the size of like Nike Jordan, so shoe-sized embers flying through the air. And the winds here in LA reached almost, I think it was 100 miles an hour or plus. So that really makes sense. How a fire can spread so aggressively is through these embers and through these intense winds.
Well, and if you imagine too, like if you have ever like done a fire, like a campfire or a fire in your chimney with like real wood and real flames, not like, fake
Not
stuff,
a flame, yeah.
not a screen. Sometimes the wood like, kind of like bursts. There is little burps and you have little, sparkles, right? Well, if you imagine the scale of a wildfire where there is like trees, like giant trees, cars that are getting on fire, things explode, right? So the embers just get kind of like shooted out and about. And then that plus the power of the wind, especially during those LA fires, I mean, it's like you're shooting rockets of embers all around, and so on, right? Like the ember lands, starts another one, and it just keeps going infinitely.
And they called it the winds here were so bad, they called it a firestorm, actually, right? Like it escalated to that scale. But anyway, so I think it's important to understand those three ways that fire spread because they correlate to actually design solutions. But a big part of creating a house and a property that is more fire resilient or resistant is understanding the vegetation. So direct flame contact is one way that it spreads mostly because of vegetation, right? A lot of people's properties have, grasses, plants, and shrubberies and trees and things that are not necessarily well maintained. And so those might be very close to each other and they're very close to another, plant or vegetation of some kind, and then right next to the house. So that is a good example of direct flame contact and allowing it to spread. It goes from one plant to another, and then that one is right next to the house. And guess what? Now your house is on fire.
Basically, any plant that's dry, especially if the soil is dry itself, like there is no moisture around, like things are just it's just a field of matches. Kindling. It's just waiting, to burn.
Yeah.
But sometimes people think like, oh, like vegetation not maintained and this, they're thinking like abandoned house, abandoned property with weeds everywhere, like dried weeds everywhere. It doesn't need to be like a messy and kept to catch on fire. I think it depends on the type of planting and, during the drier season, like, some plants kind of go like not dead, but kind of like dormant, not great looking. And it's also a matter of distance between things. Like
Absolutely.
Maybe you could have some of those plantings, but just keep them way far away from your house, right?
You're getting excited and jumping ahead. So that's, the direct flame contact it's not just about the house, right? It's about everything around the house. The other that we mentioned was the embers flying. And this also points to a design solution, which we'll talk about in a second, which is embers entering the house through vented roofs and vented attics.
Which seems like, okay, if I'm an ember
right.
and I'm trying to get in the house, right? Like, what are my chances that the wind is going to carry me in the little hole in the vent of a roof of the house down the street? Like, you're kind of thinking like a chance in a million.
Right. Well, as one lonely ember, yes.
As one lonely ember, right? But again, it's a matter of like scale and proportion. If you have millions of embers flying around, well, at least like 3 or 4 of them are going to get in. And guess what? If they're big enough, like, and there is things that could burn, it's just going to catch.
Yeah. And then the third way that fire spreads is radiant heat. And really the concern there, the easy thing to pick on is your windows, your fenestration, and your glazing, which we'll talk about. So those are the ways that fire can spread. Generally speaking, when we talk about creating a house that is fire resistant, it's not just about the house. And in fact, we think about the entire property, and there's different ways to describe this, but we like to think about it as 3 layers, and this is easy to remember. The first layer is the house itself, but it's only the first layer. The second layer is the immediate zone around the house, which is described as being between 5 to 10 feet. So let's just say it's 10 feet to be kind of extra safe. So that's the second layer of defense. And then the third layer is everything beyond that, and it's the rest of the property. And each of those 3 need to be thought about in creating a fire-resistant property. And they serve to protect each other.
So let's talk about the house, right? Yeah. The obvious thing to think about is, of course, what is the material that creates the envelope of your house? Mm-hmm. Because that's what's going to stop the flame or spread the flame,
or
right?
not. Yeah, and actually it's a really basic idea and a basic approach, but it's a very important one. Materials are rated by their fire resiliency, right? So we call it, there's Class A, Class B, and Class C. Class C fire-rated materials are the worst, and you don't want to use those. Class B is like okay, and Class A is the best. So ideally, you are using Class A fire-rated materials for the exterior of your home. And basically, it means it's materials that are not going to easily catch fire. Some good examples are metal siding. Stone is really good. Masonry is really good. And anything that's cementitious, meaning it's made with cement.
Yeah, so concrete, glass, like GFRC panel, glass fiber reinforced concrete is also another one. Those you see oftentimes on like commercial buildings. They're applying as rain screen. And then you could also use, masonry or stone. Those also would, of course, not catch on fire. I mean, if you try to like get a rock to burn, nothing's going to happen, right?
I mean, there's a reason why our chimneys and fireplaces are made out of masonry.
Which is also what you see standing after the wildfires. Sadly, in the pictures, is what's left is maybe the concrete fence and the fireplace.
Yep. And the third material is metal.
Of course.
Metal is great. And look, these are all, it's not like each one of these things is going to be the only solution. It's probably using all these strategies together is what creates a truly fire-resistant house, right? Yeah. Because for the houses in the Palisades, once they actually caught on fire, giant steel beams are completely deflected or gone. I mean, it's amazing to see a wide flange that looks like a noodle because of a fire.
Yeah.
So this is also why, yes, it's the materials that are inside of the walls, inside the house that should be, fire resistant, but really it's the outer layer, right? It's that shield that we're trying to create. And it wants to be impervious, and it wants to be, again, made of materials that are not going to burn. So wood siding, terrible, obviously, for fires. There's also, the last 40 years or whatnot, there's been a lot of sidings that are made of plastics. Those are also horrible because they will burn and melt. There are more interesting materials that can be specified that are more within the wall sandwich or the wall section, right? All the layers of the wall. And one of them was brought to our attention by Matt Reisinger recently, who was on the show. And there's a plywood made by Arctic Lab, or I forgot it. He forgot it on the show, and I forget the name now. And they have an intumescent coating on it, right? And it's a layer that basically expands to create a shielding when heat hits it. Kind of talking about that specifically, I think that's an interesting solution. And it can get you to a 1 hour, 2 hour fire rated wall. So 1 hour, 2 hour means that the wall will be resilient for up to a certain amount of time. And this is kind of architect code talk. The building code specifies that certain walls in certain areas have to be rated by a number of hours.
Yeah, like of course, the wall that separates your garage from your kitchen.
Yep.
Oftentimes has to be fire rated.
Yep, exactly.
And the door has to close by itself. So if there is any incident, it doesn't extend into the house.
Another easy example is in public or commercial structures, the emergency stairwells. Everyone sees those in buildings, right? Those are oftentimes surrounded by masonry.
2 or 3 hour rating.
Yep, because they have to be rated at a much higher degree or for a longer period of time. But anyway, so that intumescent coating is an interesting idea. It's common in commercial structures with steel. So steel is often painted with an intumescent, form of paint. I think it's great. I think it's cool. But ideally, though, that is a plywood. And so what people don't know is plywood is used on the outside of your structural framing, but it's behind your exterior facade material, your siding.
Finished layer.
Your finished layer, your siding, let's say. So I would prefer if the exterior siding was also of a material that is Class A fire rated to help build those layers and not just rely on the intumescent layer behind it. Because also once it expands, right, it'll do its job to help protect everything inside. But that means everything outside of that has to be completely replaced afterwards also.
Well, I mean, if you think about the facade or the skin, the envelope of your building, the same as like our human skin, right? That has multiple layers. You grade also the different layers of the degree of burnt on the skin, right? You could kind of do a similar grading in a house, like you burn the outer layer or it got so deep like you get more and more damaged. Yeah. I think we think a lot about the walls in those conversations, but there is also, of course, the roof.
Yeah.
The roof material sometimes is not as looked at as the walls, and Here in California, it's common for houses to have like asphalt shingles as roofing, right? Because it's common practice.
It's cheap.
It's easily available. It's affordable. Everybody knows how to put it up.
Yep.
It's not a specialty item. It's doesn't require much knowledge and specific detailing. But there is also other roof materials that I think we could consider when designing homes for wildfires.
Metal roofing, clay roofing, slate. Right, slate is something that's found in more expensive houses. Slate is also a very traditional historic material, super resilient. I think it's quite brittle, if I'm not mistaken, but it's fantastic.
Brittle, but it's very common in Europe. Like you found those oftentimes in the mountains or like more, let's say, traditional regions. And when you get a roof slate, like it's for life. Like you're not going to change it.
Yeah.
And it's actually, if you see how it's been installed, it's very beautifully put together. And the guys who do that, like that's
their craftsmen.
That's their crafts. Yeah.
Yeah. The modern, what's it called? Modern McDonald's farmhouse style that has plagued Southern California, which I detest with a passion. One of the upsides of it, though, is in that, quote, style, it's a metal roof. It's a standing seam.
Yeah.
Standing seam is there's standing seam, so you can see the vertical, the lines on it, rather. It's made of metal, and oftentimes it's steel. Sometimes it's aluminum. Copper these days is so expensive. Who's doing copper? But anything metal as a roof is going to do a much better job of deflecting embers, right? And not catching on fire compared to, there's some or a fair amount of houses in the Palisades, wood shingle roof, right? Super cool looking, has that, old rust, whatever feel. Again, it's a box of tinder. You're putting tinder on the roof.
No, it's terrible. But but those homes that you absolutely detest, like it's interesting because they do have the roof, but again, it's a combination of things. If you just have the roof, but your siding is still combustible, your house is not fully protected. It's like you go out in a rainstorm and you only have rain boots on, but you're wearing underwear. Like you're gonna get wet. You know what I mean? Like,
umbrella, but only underwear. And so I was in the Palisades a couple of weeks ago, and the things that are, first of all, just anecdotally, it's seeing it in person is not the same thing as seeing it on TV. It's horrific. But the things that are standing, to your point, is anything that's concrete and made of masonry. Now, the chimneys, when everything's gone except for the chimneys, you can't reuse that chimney or that fireplace. It needs to be demolished because it's unsafe structurally. But the material's still there, right? All of the retaining walls that are just 8 inches of concrete, still there, perfectly intact. Of course, the steel, once the house is fully inflamed and the temperature is 1,000 plus whatever degrees, steel deforms. But concrete has its issues in terms of sustainability and the creation of concrete. Mm-hmm. But once it's there, it is ultra resilient to fire. And I tend to like how concrete looks too. Of course, the downside is that it is expensive.
I was reading or I saw a video online about, because the first thing that my dad said after the wildfire happened is like, well, why would you build with wood in California when there's wildfires? Which is a legitimate question for any foreigners. Like, why are you looking for trouble? Mm-hmm. And it seems like the kind of like the history of the United States was to build with wood, and it's just been carrying on, in the same for generations and generations. But we don't have to. Like, we have other ways we could build, and it's kind of I'm hoping that unfortunately with those events, like that's going to re-question how we're building and kind of reconsider, the tradition, which is not really like. It's not like you're building with stone that have been cut, by hand and whatever. Like, we go to Home Depot or, Ganal and go get the lumber and put it up. You know what I mean? Like,
how dare you mention Home Depot?
It's not like a craftsmanship that we're trying to hold on to. That's from the locality where you're building. It's a nationwide way of approaching construction that nobody is really questioning anymore. Well, and,
what's interesting, so also sticking with the idea of the materials that are in the house, but not just talking about the outer layer, where I was talking about the plywood that has that intumescent coating on it. There's also the framing itself, to your point. Like you could use steel studs, and steel studs are extremely, what's the word I'm looking for? Steel studs are common in commercial construction, and they're a bit more common on the East Coast, interestingly, for residential. Yeah. Right? Yeah. But on the West Coast, less so for whatever, reasons of things evolve. But you could certainly do that. They're
actually lighter too. Like it's light gauge. Like they're actually much easier to carry around than 2x.
The challenge with that is, again, more the access to the tradespeople who do that, right? So yes, there are contractors who have framers who do steel studs, and they're very good at it. Good at it, meaning they're at a level of quality that makes sense for a high-end custom house or just a nice house. I would also, this is a good point, it's a good moment to highlight that there is a difference between commercial construction and residential, single-family residential construction in terms of the execution, detailedness, and quality, generally speaking. Commercial things move a lot faster, and things tend to have a bit more slippage or sloppiness, let's say, for lack of a better word. And like a high-end custom house, like it's totally, and any contractor listening knows this. They know it. Yes, so do some contractors, perform in both spaces. They do, but generally, obviously, you can take someone who does a really good job at one thing and houses and apply them to the commercial. If they can work fast enough, it's harder to use a commercial person and have them jump over to this other space now. So when we talk about steel studs, it's a great idea, but that does become the problem of finding the people, having the subs or the framers who can do it, to meet your budget requirements and all that stuff. Also with material, with specifications, going inside of the walls, there's insulation in the walls, right? So we get our R values, so we keep the house cool during the summer and warm during the winters.
Right.
And you could specify different types of insulation. So mineral wool is a type of insulation, and it is much more fire resistant than the typical insulation you'll find inside of walls, in California at least.
And kind of touching on that too, like the thermal aspect of it, a lot of, unfortunately, the homes that burned were older homes, right? Mm-hmm. And a lot of them probably didn't have, dual pane windows.
Yes. Yep. So the windows are, again, the failure point for radiant heat, like we were talking about earlier.
Yeah.
And the difference between single pane and dual is that obviously one is there's just a single pane of glass, and the other there's two with an air gap between it. And the dual pane is much more energy efficient, first of all. So all new construction, for the most part, has dual pane because it's kind of, you need to have it to get the necessary R values to satisfy Title 24 and energy codes. But the other benefit too is it's much more fire resistant because that gap between the two panes is kind of like a buffer zone. So the outer layer might heat up with the fire, will get much hotter than the inner layer, and that air gap, it's not just air, it's filled with gas, will be, again, much more resistant. The other thing with windows is the frames, right? So vinyl frames are cost-effective, very popular. We're popular,
and they still are. Though. I mean, please don't use vinyl frames.
And they're going to melt, right? So that's the other thing to consider with the windows.
Yeah, and if you don't have the budget to go like full aluminum windows or let's say steel windows, which is like way up there, mm-hmm. you could still go with like a wood clad or an aluminum clad. People call it one way or the other, mm-hmm. which is basically a wood window that has an aluminum cladding on the exterior. So you do get a little bit more resistance rather than if you had just a wood window or vinyl.
Yeah. So that is something in more of a remodel sense that one could do is replace your glazing.
If you're replacing your windows, yes, I think, maybe consider those things. It's not just about the dual pane. It's also about the material of the frame.
Yeah.
And then there is another thing, like the fire sprinklers. I feel like when you do like remodel on a home, fire sprinkler is oftentimes like, these things we have to deal with. It's like, they're going to want us to put a fire system in it and like sprinklers everywhere. And it does have an additional cost, on construction. But it is also something that could, kind of like stop the fire before everything just disappears.
Yeah. And I think we talked about on one of our previous recordings that we tend to think, meaning the general public, tends to think of sprinkler systems inside of the house, inside of the structure, which is true. But there are systems that go outside too, in the eaves, and those can start up automatically if they detect that there's enough heat. The And there's other kind of accessory things that are not so much part of the architecture, but if you have a pool, right, you can have that you can buy now, like a prosumer or consumer level, basically water jet pump, and then drain your pool and douse your house if you really need to. But yeah.
Or like even like exterior sprinklers, like those have become very much on the radar of everyone. No, on the home, right? Like there is like cheapy systems you can get on Amazon. Let's say you just put that on your roof and it just like
like not integrated into the architecture.
Yeah.
Gotcha. Yeah.
It's kind of more of a DIY, like quick, easy fix if you're not planning to remodel your house or you don't have the budget.
Yeah.
Those are the things that kind of like came up from those fires. Is those
and obviously those are not quite architectural, but should be talked about in here in this recording still, I think. But aside from like active systems like the sprinklers, going back to the design, the fundamental design of the house, we talked a lot about materials and the things you're specifying, which is like 90% of it. But the other thing that's very critical is the design of the envelope itself. And basically what we want to do now is to have a fully enclosed envelope with no holes in it, no entry points for embers to enter the house.
You want to live in a Tupperware house.
You want to live in a sealed, Gladware, whatever Tupperware sealed house that is conditioned. Old houses are very leaky, meaning not just in terms of water, but air just goes through them, right? Old houses oftentimes have a pitched roof with an attic. We all know what an attic is. Those attics have to be vented. And we'll get into the more detail into this in another recording perhaps, but those attics have to be vented because that attic space gets incredibly hot, not with fires, just with general heat, because obviously hot air rises. They get so hot, you have to have vents. And the vents are what allow that hot air to escape. So in a typical building section or that attic space, you have two vents in a diagram. You have a vent that's low and a vent that's high so that air can enter at the low point and exit at the top. That's the idea. That's the principle. And it makes sense for those reasons. However, when you have vents, those are just holes that are just welcoming embers into the house. And so those vents, if you have vents and you're doing a remodel, you want to make sure those vents you want to replace those vents, the old ones, and use ones that are of a certain type. So metal mesh is great, and there's a specificity to the size of the gaps between the mesh.
It's usually an 1/8 of an inch.
You want it to be metal, right? Because metal, you don't want to use like what do you call it, like vinyl or some kind of plastic that's just going to melt. You want it to be metal, and you want it to be dense enough so embers don't get through. That's in a remodel situation. The best though is to be ventless. So it's a enclosed, closed roof system, right? And there's no vents at all. And it's a different approach, like in terms of the building science, it's a different approach to how you deal with the roofing part of the envelope, but it's the best one. And
I think the building code is also changing to allow more of that, because in a more traditional way of building in California, they do require you to have a vented attic. So I think there is different things you have to provide, like, fire-rated materials and this and that, to not require having those types of ventilation.
Yeah, one of them is, and we're going to have a guest on the show soon who's going to talk about this in more detail. But one of them is that in a remodel situation, to do a closed roof, insulating it becomes very difficult in a remodel. Yeah. And it required ways of insulating that was either cumbersome or expensive, or subcontractors didn't like doing it. But there's a new, I forget what it's called. It's basically a ridge vent that goes at the very top of the ridge of the point, right? That allows you to insulate it in a more traditional sense and still have everything closed. Now, there is a vent, but it's only at the top. And again, you're specifying a vent that meets the criteria we just mentioned. Yeah. You've probably all seen in houses the vents that are really bad are when you have an eave and then the wall meets the eave, and on the side of the wall there's holes. You'll see them there's giant 2-inch holes so air can flow through, and that's like the worst thing. That's the worst thing possible.
But it's also kind of annoying because you could blame the building code from, having lost your home and be like, well, look, this is what was required. And guess what? It actually made it even worse because now an ember got in the attic and there was enough airflow to kind of like amplify the size of that ember and create a fire like, above my ceiling, which is silly. Like,
I know.
It's not like the fire science has changed, from when we were living in caves. Like, fire is fire.
Yeah, no, it's true. It's true.
I'm not sure that insurance companies can go after the government.
They'll reach a resolution in 200 years from now. And I want to also communicate that these closed roof systems are not an atypical, highly custom, irregular thing that we're proposing or talking about. They happen all the time. And so an easy reference that people have seen so much throughout California, again, going back to the modern farmhouse because everyone sees it, is, the great room or the living room that has a big vaulted ceiling, right? Mm-hmm. That's a closed roof. There's no attic. And it is a closed roof because there's no attic and there's no vent up there, right? You see it, and often there's a ridge beam up there, and so it is fairly common, but it's just that a lot of the houses were old and they just didn't build that way.
Yeah. Yeah, and same goes with the eaves. I mean, we talked a lot about the attic, but it's also like a house that has a roof with no eaves. There is no place, for embers to also get in because there is, like you mentioned, like ventilation on the eaves as well. And now a quick break to thank the sponsors who support the second studio.
Hey, architects, would you like to get your as-built faster? Of course you would. Well, IPX has you covered. IPX lets you seamlessly transform your laser scans into LOD 300 BIM and CAD files. Whether you've got your 3D scans already or you need a full laser scanning service, IPX offers instant pricing and order tracking for scan to BIM services on any project, no matter the size or complexity. Once a building scan is complete, IPX delivers detailed BIM, CAD, 360-degree virtual tours, and material takeoffs in their platform where you can view, share, export, query, and quantify areas, floors, and materials. Check out the IPX link in our show notes. The Second Studio podcast is sponsored by Autodesk. Do you know about Autodesk Forma? Available standalone or as part of their AEC Collection software bundle, it's a specialized AI-assisted 3D design tool that can transform early project planning. With Forma, you can rapidly model multiple massing options at the start of your projects and analyze the embodied carbon costs of different volumes, layouts, and material choices. You can then deepen your understanding of your sites by incorporating real-world contextual data for daylight, wind, noise, and more. Start your projects right with Autodesk Forma. Check out the link in our show notes to learn more.
If you're an interior designer, you need to check out Programma. Programma is the all-in-one project management software designed to streamline the entire design process. Its cloud-based specification schedules are always up to date, minimizing double handling. This means you can spend less time switching between tools and more time designing. Click the Programma link in our episode notes and use the code SECONDSTUDIO at checkout to save 25% on an annual subscription and enjoy exploring all of the other tools Programma offers.
And talking about the lower portion of the house, decks and porches, right? So obviously the material specification becomes important, but also oftentimes you'll find decks that are open underneath, and you'll find underneath there vents again, right? Because we have crawl spaces. Exactly.
Like,
we have crawl spaces.
It's an attic under the house, basically, like it's another place. It's another place for things to get in and catch on fire, and it's wood framing everywhere. So
and a crawl space, for those who don't know, it's what it sounds like. It's a space that's 18 inches to 3 feet or whatever dimension underneath your house. So between the structure, the flooring of your house, and the ground is that space. It's a crawl space because it's only big enough for someone to crawl through there. And in a typical crawl space, you have to have venting there because otherwise you're just trapping moisture and air, which is not good for many reasons. So you'll find on the perimeter of houses, that's why you'll see, average listener, at the bottom of your house, there's these vents, right, that are probably very old, that are either above or part of the concrete foundation that sticks up. That's vents. Those vents are important. They allow air to circulate for good reason. But again, entry points for embers.
But I have to say, attics are kind of creepy, and crawl spaces are even creepier. Crawl spaces don't exist in France, for example.
Yeah.
Like, that's an American thing, and I never really quite understood that because I don't know. It feels like rodents would just go live in there. I mean, I think they actually even found a bear hiding from the fires in somebody's crawl space, which is insane. So that's kind of like wrapping up the conversation about the house, right?
Oh, so last thing I'll say is that the crawl space. So there's ways to do a crawl space without having any vents. But the other easier way to do it is just to do a concrete slab. Just concrete. Yeah. So again, you just want to fully seal the house like that Tupperware that you were describing and have zero leaks. And people often wonder, well, what about air? I want air circulation. You do that with HVAC, with mechanical systems these days, right? To filter the air, to have clean filtered air come in and out of the house. But it's controlled. And it's through a system that's controlled that's not going to let fire or embers to enter. And it's actually more energy efficient. Like you do have better control over it, but it's also more efficient than, basically having air pockets in your house. Yeah. That doesn't make any sense. The second layer that we describe after, so there is the house. We're thinking about the house when we design for wildfires. We're also thinking about that perimeter band around the house. Mm-hmm. And you talked about maybe being 5 or 10 feet. And this is so usually, I think, why, setbacks exist on properties. It's not just to bother architects and create constraints, but it is also to create kind of like a safety distance buffer between you and your neighbor, right? Because if your neighbor's house catches on fire, forget about wildfires, just catches on fire. Yeah. You don't want that fire to just, like spread down the street and like burn the whole block. So keeping distances is part of it, and that's probably where setbacks are very important. It's for that. It's also for light and air quality. Places that become overly dense, they don't have light and air, and they don't feel good. But that 10-foot perimeter, fundamentally, what we want to do is clear that space of anything that will ignite, right? So you want to create a fire break. That's what it's called. It means a zone the fire will have a really tough time jumping over that zone. And so the worst thing you can have is to have a bunch of dry shrubbery and planting right along that perimeter up against the house, or even non-natural things like trash cans and other stuff like that right up against your house. I mean, keeping trash cans up against the side yard is pretty common, but there's a fire coming, move everything away from the house. Have that zone either there already or create it, as you're leaving. And that 5 to 10 foot distance is hypercritical. So ideally, you're using a ground covering that is also fire resilient, like gravel or concrete or stone and pebbles, things like that. What is it called? I'm forgetting now. The wood chips that you see in landscaping. The mulch. Not mulch. Bark. Like bark ground covering. Well, again, wood. You don't want that next to your house in terms of fire resiliency. So that's really what you want to do about in that 10-foot zone. I think that's one other thing that is not discussed enough, I think, in terms of wildfires and solutions, especially, again, if you're not remodeling your house. If you're not remodeling your house and not planning to touch it, at least like fix the perimeter around it to try and protect it from that outer layer, right? Landscaping is very important, and it's, sometimes it's not that hard. Like, again, anybody could just go to Home Depot and trim the, trim the stuff that's there. And, get some pavers, like create a path, like just kind of like keep it clean. This brings up a really good point. For the property, the landscape, and even the house itself, is that it all requires maintenance. So even if you create a fire resistant strategy in the property on day 0, but the property is not maintained correctly, some of these things don't work anymore, right? And maybe not so much for fire resiliency in a house, but generally outside of this particular specific topic, people tend to think of houses as like, I bought it or it was built for me. It's done. I don't have to think about it again. It's not true. It requires maintenance. It's kind of like having a watch, a really nice watch, or a car. It requires maintenance. I mean, especially now with the systems that are in place, everything requires maintenance and inspection over time. It's actually interesting that
like earthquake are kind of a big thing in California when we design, and wildfires. There is zones that are extremely dangerous for wildfires. Therefore, you have to like comply to like specific sections of the code in very specific zones. But, with climate change and all of that, I mean, the wildfire now, I feel like could start anywhere. And what happened to LA a few weeks ago kind of like proved us that in some ways, right? Like it's not just, that one house on the hill that was dry and there's an ember and it caught on fire and it's gone. Like it could be in cities too. And I think we should start thinking about implementing the same thing we're implementing to respond structurally to earthquake in design. Like there should be some minimal measures that we're accounting for when designing homes.
Yeah, and
it doesn't necessarily mean it's more expensive either. Like the things we're discussing about is just being mindful and aware of like the what to do and what not to do.
Look, there's no doubt that to create, talking about the structure itself, the house itself, to create the most fire-proof house ever will cost more money than an average house for sure. So some of the things we're describing, they will cost more money, but others not, right? If you're just smart about it.
Also, don't overbuild, just build better. I mean,
so that's an interesting point, because the overbuilding, the way I interpret that, means density, which means closer proximity between structures. This also maybe,
Or spend the same amount of money, but just instead of building a 10,000 square foot home, just build a 5,000 square foot home and use better materials, better everything,
There's definitely a quality over quantity aspect. And recently I was on a different podcast. Was that a podcast or a YouTube show, whatever? And I was talking about the wildlife ordinance in Los Angeles that has been pending and is still pending. It's probably further delayed now because of these fires. And anyway, in that conversation, a lot of it had to do with the limitations of square footage that one can build as a result of this ordinance if it gets adopted. And one of the things I said was like, look, this would affect people who are trying to build very large houses, which is a bummer for those people because they have a giant property and they have the money. Like, I want to build a big house, but it's not about, to your point, it's not about quantity all the time. It's about quality. And I don't know how many houses we see in LA, more in LA than in the Bay Area, that are giant, right? 10,000 square feet, 12,000 square feet, 9,000 square feet. They're horrible. They look terrible. They are probably built horribly. They flow terribly. They feel horrible. And a lot of the times they're tacky. They're done with poor taste. Like, if there was a way to rate buildings and there was, 6 categories on there, a 1, a 0 on all of the 6 categories, right? A 0 out of 10, 1 out of 10.
Minus 10.
So I agree with that sentiment 100%, that quality is more important, especially when we're talking about strategies and principles that are not just for aesthetics and for show, but they're performative for saving either lives or, again, preserving a structure so that it can still be used after it's done with minimal repair, hopefully. Talking about that third layer, though, which is beyond that 10-foot perimeter, and the third layer is just the rest of the property. It really comes down to the vegetation in a lot of ways. Again, ideally specifying, we're not landscape architects, but specifying plants that are more resilient to catching on fire. Like, I know that succulents, I know very little about plants, so I shouldn't be talking about it, but I know that succulents are very good at being fire resistant compared to others.
Well, they're filled with water inside of them,
yeah.
Right? Like, they're not like a dry stick, you know what I mean?
Yeah.
It's like, if you look at the desert, what kind of plants do you find in the desert? Cacti, succulents, anything that basically is filled with water will be fine. And those are also drought resistant, so you also don't really need to water them during the summer, which is kind of a win-win because they help you protect you from wildfires, but also, you don't have to like kill your water bill when it's like hot season in LA and you're not supposed to use water to water your plants. So really...
And that's also where it's really about working with a good landscape architect who understands these things and will work with you, the client, to integrate these into the design and work with the architect. It's also about the density of the landscaping of the trees and the shrubbery and whatnot. So as a general rule, the further away we are from the house, the more dense the landscaping can be.
Right.
And the closer you are to the house, the more sparse it wants to be, because again, it's that principle of direct flame contact, right? You don't want the flame to spread from one thing to the next. And so the further away, you can have denser things the further away, but when you get closer, you want things to be sparser for the purposes of what we're talking about. Water features are also, I mean, architecturally, sometimes they can be tacky, but they can also be of a great benefit. And even sprinkler systems. They have sprinkler systems now that will self-activate when they detect that there's enough heat and there is a fire or a impending fire.
Yeah, and actually, I mean, pools, proved to be a really good resource during the LA wildfires. A lot of people use water from their pool,
yep.
To kind of like hose down the grass around their house and their roof, cool down the roof, and do all of those things. So I think there is ways to be smart in designing so it's a pleasant lifestyle, but it's also things that are extremely usable when it comes time to do so.
Yeah, and those are the 3 layers. But you brought up an interesting point earlier about kind of the neighborhood scale. And I think it's a good one because, if you have one house and you're in a fairly typical suburban setting, so you have houses around you, whether or not your house withstands a wildfire that's approaching your neighborhood is partially dependent on what your neighbors' houses are like, right?
Yeah,
partially
yeah.
or greatly dependent on that. It also gets to the subject of fences and things, which fences can be used to block. I'm generally, for the sake of the design of the neighborhood, building tall fences everywhere is not necessarily the great thing.
It's interesting
right?
because on the topic of fences, to be European all the way, right? I remember growing up in the hometown where I'm from, and everybody in Europe, typically, I mean, at most, normal, typical town would have a fence around their property. Maybe if you live in the mountains, then that's a whole other story, because go put a fence up in the mountain. Like, why? It's not like you have a neighbor next to you.
Keep the bears
out.
The
goat from the neighbor is going to come in. Like, who cares, right?
Yeah.
But in a typical, French town, suburban or whatever, everybody has a fence around their property. And I remember there was this one house a few streets down from where I grew up that had no fence. And for everyone, it was like, wow, this is so unusual. And I remember biking, as a kid, in front of that house often and looking at it and seeing the front lawn and all the, the flowers. And I'm thinking, wow, I could just go and walk around this house. There's nothing that's, telling me you stop, this is not your property.
Right.
And I always found it very, very fascinating. And that is something that's very typical of, I feel, American suburban neighborhoods, right?
Yeah.
Is those big green lawns and the blurriness between what is, owned by the street and what is owned by the person who owns that house, and where is the property line. Things are kind of blurry in the nicer neighborhoods, because not all neighborhoods are like that.
Interesting.
And it is a very nice feature. There is it creates a landscape of the street where, for example, where I grew up, everything was very regimented.
I mean, I think
and one could only enjoy the courtyard if you're on the other side of the fence.
Right,
you know what I mean?
right.
No one else can.
Right. Well, I think the white picket fence is a very American thing, but in Venice, Venice Beach, Venice in California, not Venice in Italy. There are these really narrow walkways, but there's a neighborhood that's separated by just a pedestrian walkway that's only 5 feet wide. So it's not for cars. And X years ago, there were no fences, and which is an amazing experience to have a 5 or 6 foot wide side walkway that's of concrete, and you have a neighbor on the left and a neighbor on the right, and they all have the front yards and these houses and quaint, beautiful Venetian homes that are very eclectic, and that was kind of the experience. And over time, because the building code allows it, I suppose, and also because folks became more concerned with security or wanting privacy, people built fences that were, I don't know the height, maybe 42 inches tall, 5 feet tall, something to that effect. And now everyone has these 5 foot tall defense perimeter things, which, in terms of fire resiliency, yes, it helps. But in terms of the atmosphere and the experience of the neighborhood, the vibe, it's kind of sad, right? Because I understand everyone wants privacy to a certain degree, but that sense of community and that pleasantness that comes with it is just gone, right? Because now everyone's shielded. And I say that now because I think for a lot of people, and especially the wealthy folks who are doing custom houses, the security aspect of a house and in life is becoming more and more important. We've seen it, right? The safe room industry has skyrocketed the last 10 years. The panic room, right? And I get it, but I'm also just generally from a design kind of perspective, like a little worried that when we do this, it's to the detriment of the community.
Of course it is.
And I think that points to another aspect of this conversation, which is we've talked about the fire resistance and resiliency in design. That probably should not be the only thing that dictates the design decision making for an architect, or certainly for a client. And I also say that because it's very easy for people to zoom in on one thing that's easily quantifiable and easy to kind of like hashtag and grab onto and say, this is what I'm aiming to do. I want a fire resistant home, or I want a whatever home in this home.
I mean, you can have an awful looking house that's fire resistant. You know what I mean?
The reality is what makes a home a great home for the individuals in it and for the neighborhood is not just this one sliver. This is one of 100 things an architect would have to consider. And I think that's very, very important to remember. I think clients make decisions in terms of this type of house they're trying to create, or even sometimes who they hire, because they're kind of seduced by one thing.
Yeah.
But it's not that, right? Again, there's 100 things that have to be considered to create a house that feels good and is safe. And this is just one tiny part of it.
But I'm
an important part, but one tiny part.
But as sad and terrible as the LA fires have been, I'm actually very excited about like the rebirth of the Palisades and Altadena and those areas that are basically like gone, right? I'm very excited to see like the newness that's going to come from that, because again, it's not just one house that goes burned. We're talking about streets and neighborhoods and communities and friendships of people and people's childhood memories and childhood homes and all of that needs to be rebuilt. And because of the circumstances, I think people are going to be careful. I'm hoping they're going to be careful of how they're going to rebuild, and what they're going to rebuild. And I'm hoping that what's going to emerge from those areas is going to influence the rest of California and maybe in other states on like how we should be looking at building a home now in like 2025 with the challenges that are coming to us.
Yeah. And will probably occur or repeat at some point in time, in the same area or somewhere else.
Yeah, and we were talking, we had guests, I think it might have been Matt Reisinger, from like Texas, where they also have a lot of wildfires, right? I think we always assimilate wildfires with California because unfortunately it happens and it's in the news all the time. But there is other regions in the state and abroad that have those wildfires issues. Yeah.
Well, there's the bigger topic of just general building quality that should be employed in every structure, regardless of factors, right? Because we have the technology, we have the science, the data, so we should do it a certain way. The reason why it is not done to that standard all the time is kind of complex, but it's cost. That's one thing for sure. But also it's because, frankly, you have a lot of crappy builders and crappy architects who don't know, and they're perfectly fine peddling the crap to clients who don't know any better, right? And yes, there's a cost factor, but sometimes that cost factor is very minimal. And I get the sense that for a lot of people, if they knew of alternate ways, they'd be like, yeah, okay, it's worth the extra 5% of construction costs to do it this way. But if you're not working with someone who's good at their job and they're a true professional, you don't know about it. Yeah. And that's now we're getting on tangent, but that's the real challenge and I think frustration in the building industry that good professionals have, is that we're kind of marred and plagued by these other people who are just
yeah, that's where I'm also very, as much as I am extremely excited and optimistic about, rebuilding of the Palisades and Altadena, I'm also very scared about people jumping the gun and kind of like building way too quickly and kind of taking shortcuts and not doing the right thing.
Yeah, I know.
And that's, I think there's lessons that we need to learn from how the homes that burnt were built and how they failed and how we shouldn't repeat that, right? Yeah. Even if you're planning to live in your house for 5 years and selling to the next family, I think we should still be thinking about building in a way that lasts in time and is not just gonna, get remodeled or like disappear in another fire. Like that's what's the point?
Yeah, no, absolutely. So those are the 3 layers. If anyone has further questions about any of these things, feel free to reach out to us. Again, our office, we're helping a few folks with probably a rebuild. It's not going to be classified as a rebuild, I don't think, but we're rebuilding a property in LA because of the fires. And the way that we operate as an office and through the show, as you can probably tell, is to just try and be helpful. And so that's a long way of saying that if you know someone who lost a home, or even you're an architect and you just need resources and information, contact us. It doesn't matter that we don't work with the client or that you're an architect and therefore we're not going to get a project. I don't care about that, right? We just want to be helpful. So if you have any questions at all, big, small, reach out to us and we will either give you answers, figure it out as we do every day in the practice of architecture, solve problems, or put you in touch with someone else who can figure it out for you or give you an answer or be a better fit for you.
Yes, and if you need to reach out to us, there are several ways you can do it. You can either go on, of course, our office website, which is famearchitects.com, the podcast website, which is secondstudiopod.com. We also have the hotline, 213-222-6950. You can find both the podcast and the office on Instagram as well, Second Studio Pod and Fame_Architects. That's pretty much it.
Yeah, we're everywhere.
And so of course, we're on YouTube. There is a whole lot of episodes out there. The website has all of our episodes too, and we have more content about wildfires that's going to be coming out. So make sure you subscribe and keep an eye out.
Yep. Thanks, and talk soon. Bye.
Bye-bye.